Hello guys, how are you? I hope you remember about the things which discussed in our last session, and it was generally based on performance analysis and the comparison between various frameworks on Hadoop ecosystem. So firstly we checked Hive on MapReduce, then Hive on Spark, and finally we checked how the queries were performing on Spark SQL. And we finally concluded to a result that Spark SQL was very performing well and Hive on MapReduce was not so good, and it was sluggish in nature and it was taking time to execute our queries. Now, today our main focus will be on MapReduce framework, that why the jobs are running slowly on MapReduce, why it is taking time to execute a simple query also, and on a smaller data set also, it takes some time to start a job, so that becomes a problem area for us, and which causes the performance to lag. Now, we will enlist the reasons one by one and we will check that why it is taking too much time to launch our jobs, right? So, first of all, the as we mentioned, the launch time which is required in our MapReduce process is high. So, why it is high? We can see from this diagram here. In our yarn cluster, first of all, whenever we fire any query on even in Hive, or suppose if you are running a MapReduce job, then it asks for some resources from the resource manager in the cluster. Now, from that resource manager, it assigns a container on some node manager. Now the application checks that okay, if the dataset is small, whether that task can be performed locally or not. Here you can see that in this container, if it will check, the application master will check that okay, if I can perform this task locally, if the dataset is not too huge. So in that case, it will perform this task here only and this process will be completed. But in case the dataset is large and the dataset is more than a GB or 2 GB or even huge than that, then in that case it needs more containers, because locally it can't perform everything on its own, right? Because our cluster is busy and on this node manager, maybe it is occupied by other containers and other jobs which are running at the same point of time, so it is not able to handle that task locally. But the client application then asks for more resources from the then resource manager checks that which nodes are free and which nodes have the capability to execute few other containers. So it picks few other node managers and few other data nodes on which this task can be run. So finally it executes the task on the number of nodes and return backs the results to the client application. Now the thing to notice here is, whenever you fire a query, it takes some time for the resource manager also to check which nodes are busy, which nodes are free at that point of time, which can run our job, whatever are the job configurations required. I mean, if the data set is huge and the number of blocks are there are more, then it will check for the free node managers or any node manager which has capability to run those huge data sets or huge blocks processing is possible on some node or not. All these complicated things are handled as quickly as possible, but still it takes some time. So that's why that execution process is sluggish in nature. So the first query, even when you fire on MapReduce, or even the subsequent query, every time it checks for the resources, and that's why it takes some time to execute our job. So this was the first reason. Secondly, when we see the stages of execution in our MapReduce job, so last time, if you notice, when we fired a query, that was distributed in two jobs. Here you can see in this picture launching job 1 out of 2, and then after this was completed, the second job was launched for a single query also. So whenever you fire a query, the internal MapReduce mechanism decides that how many stages of that job are being run, right? Even in Spark also, that the job execution happens in stages only, right? So the number of stages is decided on the amount of data which you are going to process, the complexity of data, how many stages are required, like the operations which you perform in those queries, like group by operations, order by, distinct. There can be number of operations. So each and every operations is merged, and then a logical plan or a physical plan is decided internally by the execution engines. So here in MapReduce, whenever that logical plan is created, according to that the number of stages are decided for that job, and that executes on using resource managers and node managers. So this was the second reason. Because now shuffle and sort phase is the main root cause because of which our MapReduce jobs are slow. Here you can see this is the most complex aspect of MapReduce, but as we know, this shuffle and sort phase is the heart of MapReduce. Without it, any job can't run, right? So everything is happening inside the map and reduce phase in shuffle and sort, right? Here there are number of steps involved in this. Like on map side, first of all, what happens, then on reduce side, most of us knows about this shuffle and sort phase, that how it is happening in between, and how the map outputs are buffered in memory in circular buffer. Then each map task, when it shuffles the records and partitions it into a file, it spills into a local disk, and after that on the reducer side, how map outputs are copied over to reducer machine, sorting is also happening, and then finally the reducer task is completed, and the output data from the reducer is written to HDFS blocks into part files. Now, two things to notice here. On map side, every map task write its or I can say the term spill. It spills the records or the data onto the local disk in cycles, right? 100 MB buffer is used on every map side task, and once 80% of that buffer is filled, it spills the task to disk, and this happens continuously. Because this is not happening in memory like we have Spark there, right, where RAM resource or the other network configurations are very high, so there you can utilize the resource capability. But on in MapReduce, you have some restrictions. The framework is designed in such a way that it happens step by step. So all the data is not processed at once, even on a single map task. So that happens in circular way in cycles. So this is the main reason due to which map side is slow. Still, so this was about the shuffle and sort phase of MapReduce, and in this picture you can see that there are number of mappers which are running, number of reducers are running at the same point of time, and finally the output is saved in onto HDFS files, right? So this is very time consuming process. Just because of shuffle and sort, the map tasks and reduce tasks are taking time, and that's why our overall execution time becomes more. Now, coming to our disk usage part. Now, as we know that during the shuffle and sort phase, everything is written onto local disk, right? Every map output is written to our local disk only, and then from that local disk, every reduced task picks it partitions and then merges it, sorts it, and finally writes it onto the HDFS block. So this phase is very time consuming. This is our fourth reason due to which MapReduce process is slow. Whenever map tasks are running, it writes its data to local disk once these tasks are finished, right? And then the reducer tasks are reading it from there from remote procedural calls, and finally it executes the process on the reducers containers, right? So this is the main reason, because this is not happening in memory, this is happening off disk and then in memory, right? So it writes to disk, it takes the data off disk to the reducer tasks, and then that reducer task executes that process in memory, whatever the RAM capability is there on those reducer tasks. So this is another reason due to which our MapReduce process is slow. Finally, coming to our network input output. Now, this is a common reason. This is not only restricted to MapReduce process, even on Spark or any other engine. This network output is the common reason on any cluster. So, in this yarn cluster, we know there are number of nodes, number of node managers managing those nodes. So, there are number of calls happening here and there on each machine to another machine, so that causes too much traffic on the cluster. So one machine is processing something and another machine, like we do in MapReduce, when reducer is waiting from the outputs from the mappers machines, right? So during that phase there is lot of network input output involved. So when we discuss about network input output, the racks come in picture, the distance between each node manager to next node manager. I mean, there are different data nodes which are separated inside a rack. Then the distance increases from one rack to another rack. So here we can see that there are number of nodes and the racks are different. So the distance then increases. There is a switch between switch connection between each rack to a different rack. So there is a distance and bandwidth comes in picture. So due to these reasons, we should avoid having much I mean data shuffling from here and there. So to avoid those, we should have good queries and good scripts written with us. Then only we can avoid this network input output. So these were all the reasons, main causes due to which our MapReduce process is not performing so well. Now we will discuss that are there any ideas or are there any improvement techniques which we can apply in our MapReduce to make it better, right? So let us see. These are few points which we have listed down. Like in your whenever you run your Hive queries, you can set these properties in Hive according to your needs. I mean, most of the time it works. Now, based on your data, based on your complexity of your queries, sometimes you need to avoid also these queries, but most of the times they may work, right? So you can try it. First of all, it is very important to compress your data, and the format which you apply depends on the storage formats of your files or your data, right? So if you are using Cloudera machines, the best supported format is Parquet. You can use ORC as well, but with Parquet, the snappy compression format is by default, right? You can use the partitioning strategy. Always allow the dynamic partition in your Hive tables. So partitioning is something which is very beneficial for your Hive tables. When you store your data in partitions, it stores your data into different directories. Each partition stores data in different directories. So when you query on that partition table, only that directory is being read, and it reduces the amount of time which takes to execute the query, right? Parallel execution is always good most of the time, I mean. So if your data is not huge and if it is only a few blocks of data, say one or two block, then even you don't need parallelizing your task, because when you make separate blocks or you run too many mappers or reducers for your simple data or small data, then that takes some time to launch those tasks, right? In yarn cluster we know that it takes some time to launch your to spawn your tasks, right? So in that case, maybe this property is not for you. This property is generally when your data set is huge, so parallel execution is always good. Now auto join in Hive, which we say map joins, are really important in Hive. Whenever there is a big table and a small table are joining in Hive queries, this property is very useful. So it automatically converts that into a map join where there is no reducers launched. So that saves your time in that case. Suppose one table is of GBs of data and second table is only few MBs only, I mean 5 or 10 MB. Then in that case, map join is really helpful there, right? Now, as we have checked that output is compressed, you can similarly have intermediate data as well as compressed here. Now, what is that intermediate data? As we have seen that in shuffle and sort phase, it stores the data into local disks. So if this is also compressed and the output is also compressed, the time taken for the execution is generally low. So that really helps here, right? Now, if we have a question there that suppose we are compressing this, then reducer task will need to uncompress that data and read it fully to execute it process. Yes, we are right there that it will take some time, but the cost of uncompressing that data is still lesser than your text format data, right? If you're compressing your data into a Packet format, your temporary data which is stored on your mapper's local disk, uncompressing that data is still beneficial for us as compared to using that data into flattened format, that is text format. So that's why we should apply this property. Now there are few other measures which we can take. Data compression, we have discussed that we should compress our data, then compressed Hive tables. Whenever you are creating your temporary tables, like we did in our last exercise, we created this temporary table in Packet format only, so that compresses that data, and as we have discussed, that is beneficial for us. Then you should use partitioning and bucketing on your Hive table. Most of us knows how to use that process and dynamic. So partitioning and bucketing are some good practices to have in our Hive execution, which really helps. And finally, you should have your queries merged. I mean, whatever your queries are, if you can accommodate those queries, two or three queries into one, and maintaining the fact that it shouldn't overburden your map tasks or reduce tasks. I mean, if it can handle those merged queries at once, then you should apply those complex queries as well. Because if you break those queries into multiple steps, then it creates multiple files for each temporary scratches. So that adds up to your overall time of execution, because it takes some time for the map and reduce tasks to save that data onto local disk. Then it finally the reduce task save it to hdfs block, and then again the next stage or in the next query, it again reads from there and again executes it. So number of steps you apply in your execution, more time it takes, right? So number of temporary tables created, if the number of temporary tables are created which are less, then obviously it will take less time to execute your overall process, right? So MapReduce. So there are not much scenarios where MapReduce is beneficial for us, but still we have jot down few points where you can still prefer MapReduce over any other execution engine. Like in case where you are running historical data and you are processing your historical data, your batch applications, and suppose your data is in petabytes, then you can use MapReduce. There it will be very beneficial because that will be a huge amount of data. Suppose you use Spark, then it may require some more amount of resources compared to MR, and it may fail at that time. So in that case, MapReduce is good option. Now when job completion time is not important for you, then you can use obviously MapReduce, because it may take an hour or two for your huge amount of data as compared to Spark. But still, if that is not a constraint for you, you can run your jobs overnight, and you can still complete your batch applications or any other processes. In that case, you can use MapReduce, where your completion time of the jobs is not an overhead for you. And then when you use MapReduce, the RAM requirement is less, because in Spark we know that everything is happening in memory, and there you will require a huge amount of RAM for each executor which Sparks launch. But in MapReduce, if your RAM is less, because it spills your data, or I say intermediate data onto disk, so comparatively it will require less amount of RAM. So in that case, MapReduce is a good option. And finally, the advantage of MapReduce is it is more failure tolerant as compared to other execution engines, because of the RAM requirement. It requires less RAM and for the processes, and it stores your data or intermediate data onto disk, and off disk it reads, and then in memory is happening. And also we have seen that during shuffle and sort phase, the processing is also happening in cycles. So in that case, it is a safer option when you are processing your petabytes of data to use MapReduce, because it is more failure tolerant as compared to Spark or any other execution engines. So in that case, you can prefer MapReduce for these options. So guys, that is all related to this topic now. We have seen the reasons due to which our MapReduce process was not very well performing, and what are the improvement areas, and what are the good options that we can use to tackle the slowness of MapReduce jobs, and in what application and where should we apply our MapReduce framework, and where we should avoid this. So we have seen everything. Now this video concludes here, and please don't forget to like and subscribe this video and this YouTube channel. Thanks for joining, guys.